Recording?
Yeah, so I just clicked off the recording and we'll go from there.
Who's taking notes?
Either does someone want to volunteer to take notes?
You want to take notes?
Sure. I can do that if you want.
Oh, sweet. Okay.
So, Christopher, do you want to do it, or should I do it?
Go ahead. Please take notes.
Cool. Yeah. So my part's going to be really short before I hand off to Piotr, who's going to give the update. I just wanted to note that we wrote a design doc to go with the branch that we have, and that's linked in the agenda right now. So after the meeting, feel free to take a look and add comments, concerns, questions, all that kind of stuff. Yeah, take it away.
Okay, let me share my screen. So this is a design document, what we've prepared with Connor. So the main update since the last demoing part is that we handled all of the C group resource control to the kubelet. There is no write inside the isolator. We've just in our POC enabled the let me find it. It will be right here. We enabled the CPU set CPUs, and kubelet itself is pinning the pod to the specific CPUs. The only thing which is done in isolator is discovery, advertisement, and scheduling, somehow scheduling decisions. So maybe I will go with the flow. So the isolator is advertising the opaque resources, which was discovered during the discovery phase at the start of the isolator. Then the opaque integer resources are being advertised to the node. And then when the user of the Kubernetes cluster wants to use the resource, for example, CPU set CPUs, he just use it in the manifest. And then when it comes to our isolator, it received the pod spec. Let me show you the protobuf right here, the event type pod press start with the pod spec right here. And then we just check if the given node is able to pin the desired count of CPUs to the pod. So basically, this is another check, because first is with opaque resources. So then we are almost sure that we can pin this pod, and then we just specify the specific cores. So for example, 1 and 5, just with the format that CPU sets are accepting. And then we return this information in the event reply. Event reply is here with the C group resource and this type. And then the kubelet is doing the writing part. We enabled this subsystem in the kubelet, and lib container is pinning pod to the CPU. So this is basically the update since the last time. And you can see our POC on the Intel SDI-X branch. Just, I will show you.
So previously, I think the last time you demonstrated this, every pod that got sent through your isolator got scheduled to the same CPU. Are we doing any differentiated, like have we passed more to the code here to make a differentiated decision?
Yeah, I can show you. Maybe this one would be better, this PR. Right now, okay, so this is, we just say that, for example, in the opaque resource right here, we would say that this isolator is advertising core affinity. For example, if you have 8 cores, it will say 8 cores. And then if the manifest is coming and it says, like, for example, I want 4 exclusive CPUs, the isolator will pass to kubelet information. For example, you can take from 0 to 3 CPUs. And then if there is another pod which, for example, wants and of course the opaque integer resources will be decremented, because this is how we discover CPUs. And then we keep the state of the CPU topology in memory, and we always know which CPU to give to the pod. So we always give the unique CPUs to the application right now.
So I just wanted to add a kind of a clarifying statement, which was that the strategy that Piotr is describing is just an example of the isolator implementation. So, you know, any core pinning strategy that you can think of, you could implement in the isolator. The one that we happen to implement is the one that was just described, which is, you know, exclusively allocate, you know, a certain number of cores to each pod that asks for it. And then, you know, if you wanted those to be, you know, exclusively used by those user pods, you would have to do extra work, like use ISIL CPUs and maybe taints to keep other pods off of the node that don't consume the OIRs. But this was meant to be just an example of how the API could be used.
Yeah, I mean, this is awesome. I think like with whatever is shown today, we sort of understand how it's possible to have like custom hardware topology awareness, essentially. There's also the other use case of like dealing with like additional hardware, where or a specific request for some other resource that's not known to the kubelet, trying to inject that in the right possible means is another open feature. And how topology and like identifying new hardware would sort of work with each other is also a very interesting use case.
Google.
These are the things that we have to do, but we can get a full idea on like how the
You kind of cut out a little bit, Vish. Could you say that last part again?
Yeah, so I was saying that like we dealt with one use case here, which is that of like having custom isolation policies based on like hardware topology. Other use cases that like if we have additional hardware devices that are not understood by kubelet by default, how do we inject them into pods? And like how does the API represent it? And I think like OIR is sort of a means for representing them, but like how do we actually inject those resources? That's another feature that I haven't seen yet in this proposal or in this implementation. And the second part is the intersection between hardware topology and that of like adding new devices. How do these two things interplay? Like if the kubelet is dealing with, or if the kubelet has its own hardware topology awareness and it's making some decision, and if it has to like inject new devices, how would that work and how would that interplay? Because like it's not necessary for us to like replace everything. Like the case with the scheduler, writing the whole, like forking the whole scheduler is going to be a big pain for everyone to manage once they fork it. Similarly, in the kubelet, we could imagine that like if the API were to be extensible, where kubelet decisions are being made, which would then influence the additional hardware requirements that are being presented to like these third-party isolators, then that might actually be useful.
Yeah, I think your thoughts are directly in line with some of the ideas that we had for extending this. And there's some discussion about that in the design doc that's linked in the agenda.
Okay.
I know you haven't had time to read it. We just put it in there 2 seconds ago. But yeah, definitely, you know, adding additional information in the reply that the isolator sends back to the kubelet, I think is, you know, it seems like a clear way to add support for other devices. So you could add, things to the device whitelist. You could inject environment variables. You could maybe add volume mounts to mount in necessary libraries and whatnot. I think there's a lot of possibility here, and the fact that the kubelet ends up being the writer of the C group kind of simplifies some of the questions about how all the isolators are supposed to coordinate, because the kubelet can encode a policy of precedence, where maybe if no isolator returns information for a specific vector, then maybe the default policy just takes over. For example, there could be other policies we could think of too, but at least it gives us a place to work, maybe.
Yeah, I completely agree. I think I'll post my thoughts or comments in the doc. That way it's easier to coordinate. I just want to add one more thing since you mentioned policies. I didn't see the updates part. Like I only saw the pod creation workflow, but then there's the part where like as new pods get added, you might want to change your previous allocations, or you might want to rebalance, or maybe you just like keep continuously changing how the system is behaving based on like SLOs and things like that. So if the kubelet were to have its own inbuilt topology awareness, for example, it will probably be rebalancing over time. And so I don't see how a third-party isolator in this case would be able to rebalance. But that's something. But that's a thing to consider.
So there's it's listed as a possible future extension right now. The only events we emit to the isolator are pre-start pod, which is during pod C group or pod level container creation, and post-stop pod, which is after the last container in the pod goes terminal. But we could add a sync because, we're catching calls from ensure exists periodically. And so we could maybe delegate to the isolator at that point.
Okay.
But yeah, there would need to be some kind of coordination. Maybe, I don't know, we can talk about it in the doc, but yeah, that's a really good point.
Right. And like the recent discussions have been around like having a default implementation in the kubelet that sort of understands basic topology. So I'm also curious, like if the kubelet were to understands, or if the kubelet were to manage some of these resources natively, then the policy needs to take into account that. And so the API has to reflect that as well. Like if the isolator is specifying a CPU set, for example, and the kubelet has already made the decision, that there shouldn't be like conflicting situations on the node. So there should be a means to like express what capabilities are being granted to an isolator, and that's what the isolator should be working towards.
What we did, at least with Mesos, was to version it. So a plugin would only work against a certain version of Mesos, like even like a minor version. So you would have to bump the version of the isolator as well, knowing that you've tested it and the new version of the kubelet will have like some policies inside of it versus others. Okay. So that's at least like you have to explicitly say this isolator now works with, in our case with Mesos.18 something. So here it could be the same thing, saying you need to, as a isolator writer, be extremely aware of what the kubelet does and does not do.
Yeah, so
I think though even in the long term, the kubelet itself, as it becomes more, I guess, topology aware, needs to support gracefully shutting off its defaults, right?
Yes.
So it's not a matter of just granting to the isolator what you can do. We also need to be able to tell the kubelet not to do what it might desire to do.
Yeah, I completely agree. Like how that API would work is something we can think of. It might just be through configuration, which is external to the kubelet and to the isolator, or it could be some negotiation that the kubelet and the isolator does. But that's another facet that we have to capture a little bit at least, and we can iterate on that over time. But I just want to say it out loud. I'm hoping that, like as part of I think this is part of our agenda. Like once we decide on like whether Kubernetes is going to take on some form of like hardware topology awareness in the near future, and if it does, then I'm hoping that like we would focus our energy on the default implementation first before we come up with like multiple other alternatives to that, because then it will like completely fragment the ecosystem and I mean, you'd be sending confusing signals to our users.
So I think what we need to do when we decide that the kubelet's going to do the default is identify clearly which workload the kubelet's optimizing its default for. I think it's very likely that, you know, in past meetings, Jeremy presented like 10 different verticals, it felt like. I'd like to understand which of those verticals we think the kubelet's default is best fit, because I think when you guys discuss this, it's like the Borg use case, and I think there's a lot of verticals where that is not the best fit.
I completely agree with you. I don't think like Borg dealt with all the 10 different verticals, but it did deal with 4 to 5 verticals at the least.
Yeah, so I think what we need to do before we say like where engineers should prioritize their time and effort, like I'd like to understand if like, is the kubelet default ideal for animation studios? Is the kubelet default ideal for network operators, right? Is it ideal for each of these workloads? Because I think realistically vendors are going to have to go do stuff in the spaces for the customers they're serving.
Yeah, that's a great point. Yes, I completely agree with it. I'll try to collect some information about that as well as part of our face-to-face meeting.
Yep. Okay. So with that, maybe it's a good time to shift topics. Connor, is there anything else you guys want to bring up for today's presentation? Otherwise, I think homework will be to go read the doc that you just posted.
Yeah, I think that was it. Just a few updates, and you know, we didn't do a demo again because it would look largely the same as last time. But yeah, I think that's it. Thanks for comments. That's great.
Okay.
Thanks a lot for prototyping this, by the way. This is what is going to really help us move forward.
So that, Vish, do you want to give a summary on the face-to-face stuff or give any details? And then
yeah, let me share the doc that I had, which might make it easier to understand the decisions that were made. Yeah. Is everyone able to see the doc?
Yep.
Okay. So TLDR is that we decided on a schedule that's going to be from the 1st of May to the 3rd of May. So it's from Monday through Wednesday. And the location was not new. And I'll go over why we decided the schedule and the location. So based on the initial survey, we got a bunch of topics. And given the extent of topics we had, we felt that like we need at least 3 days. And I'm really not sure whether we'll cover all of them in the 3 days, but at least we'll have actionable work at the end of those 3 days, which we can take and then like we can continue working, right? Like we're not having the issues that we're currently having with virtual meetings where we're all like discussing a few things and we go back to our own work and then we come back and then like we haven't made progress. So hopefully that wouldn't happen again with the in-person meeting. So we decided that we need at least 3 days. And then based on the feedback we got from the initial survey, people are spread apart across various regions, and West Coast seems to be the most dominant one amongst attendees who actually responded to the survey. And I know for a fact that there are a few Googlers who did not respond to the survey because there was KubeCon and a few other events that were going on. So with that in mind, we decided that like Bay Area might be the best location. So for now, I've listed Google as the, I don't think there's a requirement that it has to happen at Google. So if anyone else in Bay Area wants to host it, just reach out to me or direct. And in terms of like preferred start dates, the survey basically had dates all through April. So there was like not a single date that was dominating. And then we took into account a few other issues. The storage SIG was meeting during the week of 11th. And there was DockerCon, and a few people are going to DockerCon. And then the last week of April did not work for a few Red Hatters and me personally as well. And then there was OSCON, and there's like a whole bunch of every week basically has some conference or other. So it's basically a question of like, which week do we choose, and like what's the best compromise? And so we decided that like we choose the first week of May, since it worked for most of the organizers and it worked for everyone else as well. And I really apologize if that's not the best time for some of you, but I mean, we really don't have much options here. So please RSVP. I think you should have gotten an RSVP survey already. So please RSVP to that, because we have to like make sure that whoever is hosting has all the names, and so they can take care of security. We're going to use this doc to coordinate the agenda. If you cannot make it to all 3 days, we'll try to accommodate your topic of interest on the day that you would be attending. But given the amount of interest, we have to limit the number of topics. So I apologize early on if your favorite topic isn't being discussed. We'll also try to have a VC setup, but personally speaking, VCs haven't been great for large meetings in the past. So if you're really, really interested and if you want to actively participate, then I would recommend showing up in person. But if you're just going to hear it, then a VC might just work for you. So we're curating the goals here. Like we're trying to figure out what the main topics are. I've listed a few, Jeremy has listed a few. So please go ahead and like list some of the topics, and we have to prioritize this based on what is most important for 2017, for example, and like what is most important for the ecosystem. Yeah, I guess that's about it. Any questions?
So can you share the link for this doc in the chat, if you don't mind?
Yeah. So a link to this doc is in the RSVP survey, and I sent an email, and the email also has a direct link to this doc. So I sent the email to SIG scheduling, SIG node, and SIG autoscaling.
Okay, it's just if you had it handy, then I would put it in the meeting notes.
Yes,
I can put it in the meeting notes right now. I have it open.
Yeah, that's a good idea too.
And we were looking to get answers this week, correct, Fish?
Yeah, that's right. We're hoping to get a complete list of attendees this week. So please RSVP, and anyone in your organization or any of your friends or people whom you work with would be interested, please pass on the word to them. And this is going to be highly technical, so there are going to be no presentations. So if somebody is going to show up just to learn what's going on, this might not be the right venue for them. So just choose appropriately.
Okay, so I think that covers the face-to-face. Hopefully a number of people are able to join who have been interested in this topic. And I really think some of the stuff that the folks at Intel are doing are helping to give us experience on the topics we've been talking about. So it's a big thank you to you guys. With that, I think the next item on our agenda was the pod preset discussion. So
yes, can you hear me?
Yes, we can hear you.
Okay, so this proposal, which I just sent out yesterday, I edited overnight as well. Actually, I should probably present, I guess, even if it's just a GitHub page. Let me figure how to do this. Desktop. Can you see? Can you see my screen?
Yep.
So this came out of the problems we've been having deploying GPU containers, because we need to inject libraries and binaries into the pods, and right now we have this giant mess of YAML files with always the same stuff copied over and over, And we would like to simplify that also because if we come up with some kind of like open source software, we cannot easily share because the host paths that we mount into our containers are probably not going to work for other people as well. I found out that in 1.6 there's already a pod injection policy object, which serves a very similar purpose, but it's not exactly, it's not going to work for us because it just discriminates based on label. We want to do the same, but for when a pod actually uses a resource. So in the specific case, I have a bunch of example here. I want to run TensorFlow, and I want to have to send out a YAML file that has paths then people have to then later edit. And also I want the YAML file to work on my workstation as well as, let's say, GKE or some other Kubernetes cluster hosted by another company.
Before you continue, can you give a little more detail? So pod preset today basically lets you do environment and volume variable injection into containers.
Yes, I can show you the proposed changes. So this is what you see here, the pod preset spec. This is the existing object. It lets you select pods by label, and then if there's a match, by labels, sorry, and then it lets you inject environment variables, volumes, and volume mounts. So the idea is that you, as an administrator or as a user, create this once per cluster or per namespace, and then all the, for example, all the pods that have a specific label will be modified at creation time. My idea would be to add a second selector that is going to match special resources. And
so yeah, that's what I was trying to tease out here a little bit, which is, so for pod preset, right now it handles these two things. It's arguable that like in the future, pod preset could take on some of the defaulting capabilities that say a limit range resource supports. So
yes.
If I had to propose that not only do I want pod presets to handle environment and volume mount defaulting, but also resource requirements defaulting, does that conflict with what you'd be looking to target? Because like if it's also the one that's going to be defaulting resources, then it can't be selecting on those resources.
I guess it would have to be for non-overlapping resources. Like if I match on GPU, maybe I shouldn't be able to set defaults for GPUs, but maybe I can do it for CPU and RAM. Does that answer your question? I cannot think of a...
I guess what I'm trying to wonder is like, I just wanted to call out that it's been speculated that pod preset might do default resource assignment in the future. And so as a consequence, using resources assigned as a selector might be problematic. And it'd be good to know like if that would be problematic for your proposal here.
I cannot foresee, I don't know, right away I cannot foresee any, realistic problems, but it could be there's some use case I haven't thought of. I can maybe address this in a revised version of the document.
Derek, just another thought to whatever you're saying. I think the ordering matters, right? Like limit range is serving a purpose, and then pod preset.
I can't hear you. Your volume is very low.
Okay, can you hear me now?
Yeah, it's better. Thanks.
Okay, so I was just saying that like the ordering basically matters, right? Like limit ranges are serving some purpose, and then pod presets could be serving another purpose, and then there could be another defaulter that takes care of like resource classes, for example.
Right.
Amongst all these cases, it's the ordering of defaulting that matters, right?
Right. Yes, actually, it's one of the open issues that I mentioned, and the same applies to the pod presets. Right now, the pod presets are applied in order, like oldest to newest, I believe. So, and one example I give is that if you manipulate a path variable, you're gonna be in trouble because one policy sets a specific value for the path variable, and then the next one will just override it. And the user is going to expect that you concatenate the two, but for that to work, you have to make a lot of assumptions about, are you running a Unix container and so on. So it's not an easy problem. I don't know that there's an easy solution to that. And also there's overlap with I've seen the NVIDIA proposal. So in their proposal, they would take care of some of this already, but this is more generic. It can be applied to other resources as well, like opaque integer resources as well. One of the examples I give is, let's assume you have some kind of local SSD disk that you want to export as an opaque integer resource as well.
I mean, local SSDs are being dealt with as through like.
I'm sorry?
Local SSDs are being dealt with through persistent volumes.
Oh yeah, that was just the first example I could think of, as some kind of unique resource that is per host, and it's yeah, that would be something else. Yeah, I can probably come up with
quantum number generators.
I'm just not sure if it's necessary to like have the API object represent all forms of like selections. I mean, given that there's also like, I'm not sure whether this is already implemented, but there was discussions around like having extensible defaulting, right? So if we can, it could just be a custom defaulter that we run. We don't necessarily have to represent defaulting very generic. Like having this use case of like saying that if the number of GPUs are more than 2, then do something like that. That could just be a custom defaulter.
Yeah, the main reason why I proposed it is that there's already a mechanism in place, the pod preset. So, rather than having some other entity, this felt like it was a close match. But I'm not, it's as long as there's something that takes care of this problem, like the ultimate goal would be something like, being able to publish an app on the Helm repo, and you don't have to worry about the specifics of where some directories are on the nodes.
Yeah.
So, Rudy,
Yeah.
Could this live in an admission controller? Maybe this is a stupid question.
Mission controller. So the pod preset already is an extra mission controller. So the two alternatives are: we either extend the existing object and controller, or we write a parallel one which does almost the same things. So yeah, it's a trade-off there. So we either go for consistency. Also, you have to then teach users about two separate objects that are similar but not identical. That was my concern.
I guess the question is like, is this a user-facing API, or is this something that like vendors would customize and not expose to actual Kubernetes end users? Like, would there be
pod presets?
Yeah, would this a file for like setting users? I guess no, right?
It's mostly an admin control. Could be the user too, depending on the case. No, so I want to be careful there. So it's very much an end user exposed entity. I mean, so when so the background for pod preset was it was as a part of the service catalog effort, where for folks who are not aware of the service catalog lets you go and look at a catalog of services. You can provision one of those services, and then you can bind one of those services into your pod. And the binding information is a secret, or it's also default environment variables or default volume amounts that you want to inject in. And so the pod preset came in here because people don't want to know how to mutate their pod spec based on the services they're binding from. So at least from anyone who's in the service catalog ecosystem, like when you create a bind to a service, a pod preset will provision for you in your namespace. But I think it's largely going to expect it to be user visible. One of the things we've run into that I'm concerned around pod presets here is like, are you assuming it's host volume pass or something that's going to be injected into? Like, what is the...
Yeah, that would be the common case, yes.
So...
yeah, this is something that is associated with the resource. Otherwise there's no point in, using this feature if it's not something specific to, let's say, a GPU or FPGA or whatever else. And also, from what I heard before, the isolator proposal has something like this where it can set variables, but that's after the fact, right after the pod has been created. So it doesn't mutate the pod, it just changes the environment after the pod is already in the API server.
Yeah. I mean, I had a very similar use case for like supporting dev SHM. I actually opened a PR a week back, which again uses the admission controller approach. So I think like we're seeing a lot of different use cases, and this proposal is going to be really helpful. At least once we have all the use cases together, then we think of the best means of representing it. I'm just a little concerned that by trying to make this API generic enough, we're going to make it really complex. And
Right. Yeah. So this is why I wanted to share it and see what kind of feedback people had. You know, even either here or on the issue on the proposal as well. I don't have any. You know, I don't have any fixed objectives here. Just to get something that solves the specific problems we are having.
yeah, that's fair. Thanks a lot for writing this up. Because we keep hearing about this, but there has not been an official written document yet.
So I guess if I was to contrast what some of the other proposals have done, I like that this keeps the volume mounts explicit in the pod spec and not like kind of hidden.
Correct.
Whether or not it's the right place, I think I'd want to do the defaulting. That's not clear to me. I need to think about a little bit on that.
Yeah, I mean, exposing node level information into API defaulting is going to be pretty difficult because you might have like nodes with different configuration. I don't know if you can expect like homogeneous clusters all around. So it's going to be a hard problem if you want to like tackle this at the defaulting level.
Would you have also defaulting by namespace? I guess you would.
Yeah, I mean, any defaulting we do around like host volumes, anything that's host dependent is going to be problematic because then we have this implicit assumption of like homogeneous clusters. Like,
okay.
But practically speaking, like people could start using pod presets for this use case if they just ensured that that a label is set on every.
Yeah, it's the main concern there is that there's going to be a ton of labels that are similar but not identical, and you have to remember which one the policy in the cluster requires. Yeah, as I say in the open issues, maybe something like Helm can set standards that people stick to. Hopefully,
yeah, but practically speaking, like someone could easily write a controller that just list watches all pods and has a resource selector of GPU and then add the label. Although maybe that wouldn't work because you'd have to do it prior to scheduling.
Yeah. Or prior to issue, because you need to inject the variable, for example. After the fact, you cannot change the container environment.
Yeah, I mean, I could think of like 3 different defaulting systems that we need, and like pod preset seems to be one of those. Like I was saying, like there's the translation from what the API that the users speak to the API that the system understands, so that like Helm charts are portable. And then the next step is like having some additional defaulting like through like pod presets, not even pod presets, like limit ranges, where we apply some policies around how resources can be consumed. The third part might be like enhancing or actually making use of which might require like nonsense. Like for example, going to a GPU workload, users might ask for like GPU food, which might get translated to a specific GPU on the cluster. That's the first defaulting, and the second part is like ensuring that the user cannot use more than X amount of GPU food, translated to. And then the third part is like injecting specific or whatever things we want to add, environment variables, for example, to actually utilize that. And I feel like these 3 are like separate use cases. Probably need like different means for addressing them.
Yeah.
So that in mind, do we want to switch then to we can take follow-ups on this on the design issue.
Sounds good.
And then I think we have one more topic today on the GPU use cases.
Thanks.
Just to continue a bit on this, the volume problem and the binary problem and basically the CUDA version problem is something that we would solve in the next version, in the solution with the NVIDIA container. So I don't think it would be, with our solution, it would live in an admission control. It would be handled by the runtime.
Oh, you mean like NVIDIA Docker, essentially?
Well, the thing is that NVIDIA Docker just basically mounts a volume, which is something which what we're doing with the new version is a lot more advanced, because we're basically mapping the different libraries individually and not through a volume. So you have more control, because then you can specify if you want, for example, compute or graphic libraries. And yeah, you don't need to specify the volume, because we're injecting ourselves under the different runtimes. Well, at the runtime level. So you don't need to specify it to Docker, or you don't need to specify it to Rocket, or you don't need to specify it to Singularity. We're just under that.
Yeah, our goal was to support multiple container runtimes. And we've been doing that because NVIDIA Docker and all the problems that we're seeing here is that NVIDIA Docker doesn't integrate well into the ecosystem. The initial NVIDIA Docker approach required a wrapper on top of Docker. And with the new approach, if you can switch the runtime, and I think with the OCI being extended, everyone is converging to that. And so we can maybe describe what we have in mind quickly. I think that's the end of the document. So Renaud, do you want to start? And maybe we can come back to the runtime later.
Well, I'm going to share my screen. And one of the, I think I'll start with just going back. I'll change a bit the subject and going back to the scheduling parts, because that's one of the things we wanted to, that wasn't really clear, I think, yesterday.
Right, yeah, let's see if we agree on the use case, and maybe users like clarify, have other use cases.
Yeah, like we discussed yesterday, let's talk about the use cases first, and then figure out what's the best technical solution to meet that.
So,
all right.
So one of the things we've, well, one of them, the knobs, we've actually, we were talking with the different users, deep learning teams and NVIDIA, and what we think and believe the users need is, of course, the number of GPUs. That's something that needs to be, that's already in Kubernetes. But the different other knobs that users usually want to tune and that have a big impact on performance would be capability and topology. And then usually different users want to have error correction and the minimum memory a GPU has. And the last thing being what's the minimum driver version their job would need.
So for instance,
for the compute capabilities, a user would specify what either an integer which would map to compute the integer compute capability,
right?
Or
equivalent to proc CPU info, basically. Where you say, you say you have for CPU you have AVX and C, and this is the equivalent. Basically, this enables hardware features and special instructions for, let's say, deep learning, especially for FP16.
Yeah. I think the minimum GPU memory is something that really needs to go in Kubernetes. ECC is something that shouldn't be very tricky to handle. The driver version is also something that shouldn't be very tricky to handle. And I think what we believe is the most important part, and what was the discussion yesterday, is should scheduler be topology aware? Should the scheduler be topology aware? And
the one use case that's not, I just want to make sure if it's assumed here or not. Are we assuming homogeneous sets of GPUs on a single node?
No.
No, we have that below actually.
Yeah.
User examples.
So all these options are are dependent on the actual hardware type versus like which ones are global to the whole node?
The number of GPUs are global to the whole node. The compute capabilities are dependent on each GPU. The GPU memory is dependent on each GPU. The error correction ECC is dependent on each GPU, and the topology is dependent on the node.
Well, actually, pairs of GPUs.
Yeah.
Or pairs or more than that.
And the driver version is dependent on the node.
So, okay.
And so, yeah, to answer the previous question, we have use cases where people might have, I don't know, 8 GPUs or 9 GPUs on a node, or well, actually 5, where one is a graphic one, a small one, that's not great if you use it for compute, because it's for visualization task, and like 4 compute GPUs that are made with large memory and so on. It's quite uncommon, but this is a use case that exists.
So going back to topology, and I wanted to stress the importance. Topology is something that varies widely across nodes, and you'll see down a bit down that we have different performance, but the pictures I'm showing is basically the most common topologies. So the first one being 2 GPUs. Well, the first one is pretty clear, is that when you have a task that needs 2 GPU, that would be, for example, a TensorFlow job, performance are going to vary widely if your task is running on GPU 0 and GPU 2, because you're going through the CPU. Whereas it could be, and the user is going to want to specify that he wants to have at least a certain level of topology. So for example, he wants to be able to specify that he wants the job to run on the switch, at the switch level, not at the bridge level.
Well, a same default here will be to always try to allocate GPU 0 and 1, and actually most of the time if you cannot, you don't allocate that. Let's say only 0 and 2 are available, and someone asks for 2. Might be the same default to just wait for more GPUs to be available instead of having a suboptimal allocation. But there are still some use cases where the GPUs are used independently of each other, and there are no GPU to GPU communication. In this case, let's say
FFmpeg.
MPEG, yeah, MPEG. If you have multiple video streams to transcode, you don't need multi-GPU
communication,
right? But still, it will be the same default if you prevent suboptimal allocations.
Another use case would be the user specifying that he wants 1 NVLink or 2 NVLinks. And in that case, you wouldn't, so for example, if you had 2 nodes and the user would be able to, the 2 nodes on the image. And it would be, one of the things our users would be able to specify is whether they want their job to run at least on a switch-based topology, or on a 1 NVLink, or on a 2 NVLink. And this gets even more complicated in the case of the DGX, for example, which adds the complexity of NUMA. And I think this is where Bish, you were basically concerned, because in most cases, you're going to want to pin the CPU. So for example, let's say you want a job that takes 2 CPU. For example, on this, I'm not sure if you can see my cursor, but it would be on the top left GPU, and then on the GPU after that. You'd want to have the job pinned on CPU 0. And that is something that that is something that could be decided at schedule level. It could also be decided at the kubelet level. It could also be decided at the NVIDIA runtime level. I think this is this is an open problem that needs to be solved, and which
again,
is going to be pretty complicated.
As you saying, default here would be to always pin to the socket and never allocate GPUs across sockets. So you don't give 0 and 7, for instance. That doesn't usually make sense if you just want 2 GPUs.
Yeah.
May I add something? Your proposal makes sense, and of course it's a valid point that we may want to have fine control of all of these GPUs. But my question is that how realistic is this to think that this is going to be possible on thousands of machines? There's such fine-grained control over like GPUs and exactly which cores is going to be allocated on like thousands of machines running probably more than just one workload. Right. So my question is basically is that how well does this problem fit in Kubernetes? Kubernetes promise, or maybe one of the very basic and important promises, is to have a system that allows you to scale your workload elastically at runtime without much involvement of humans, and allows you to move workloads from one service provider or one cloud provider to another, or from a cloud provider to your own premise. So if you go to such fine control about the cores that you're going to allocate to a workload, to a particular task, not a workload, to a particular task, or having such fine control over the driver version and everything, every little details about how GPUs are allocated, then we may sort of contradict some of these basic promises of Kubernetes. So all these are great. My question is basically that.
But isn't that something that we're already doing somewhat with CPUs? So for example, you're already having details on how much memory you'd want your job to be available. And isn't that what we're doing when we're saying that we'd want to be able to have CPU pinning? We're already giving the user fine-grained details, and we're just saying that it could be great to have the same details, those fine-grained details used.
So I guess the thing I'm sensitive to here is it seems like the presentation here does a great job on like calling out what they think are valuable use cases. I also think like some of the non-cloud vendors also have presented similar use cases where we want to get more of this information available. I don't want to like prejudge the use case and say like the use case is invalid, right? I think the use case they're presenting is things I think many customers would talk to vendors and say they want to do.
And this is most of deep learning, basically.
I think I interpret Bobby's statement slightly differently, and I'm just going to try to paraphrase that the way I understood it. Kubernetes currently supports it supports attributes at the node level. It does not support attributes at the resource level, and like GPUs are bringing up that problem. Like we have per resource attributes, and there's just no means for the system to represent that or for the users to request for specific attributes. And the second part is that one of the questions was like, does it make sense to handle all this at the scheduler level? And I think like Bobby made a great point that like trying to deal with all the existing predicates at the priority functions at the scheduler level is already pretty complex, and that like if you put all of them together, it's very difficult to wrap your head around like how the scheduler is going to behave under this given scenario. If you're going to add hardware topology to that, then that's going to make it like extremely complex. And given the fact that the node has the liberty to change its decisions, past decisions, to make sure that the SLAs, performance SLAs for an application can be met, I really don't know if it's.
So on that last statement though, Vish, I think we're pre-designing a future end goal without a community agreement on that end goal. Right? You're describing like a Google system and not necessarily the Cube system as it exists today, right? Cube today does not go and like dynamically modify things to meet an SLO. Like I don't have a way of describing that SLO other than 3 clause tiers.
Correct, but the clause tiers are from the get-go, the clause tiers were meant to represent SLOs, and they were just not some strings, right?
So at least if we're going to inject something, We've been talking about this to like a lot in the past, but there's something in between, right? Where if you express intent, which QoS basically is, right? You have some intent about how things to be realized, where, you know, if you can abstract different classes of the GPU, QoS, or come up with categories that isolators or a system like it on the host realizes by, you know, doing the right placement or bouncing it, right? So keeping the scheduling decisions fairly simple. But it's been a thing we've been debating, right? It's like, how much does the scheduler need to know versus, you know, node local decision making, where it looks at the feasibility and so like, no, I can't do this, and then bounce it.
Well,
So in that way, you kind of isolate the complexity to be on the host itself.
but there's actually two problems. There is the problem of, is it feasible? And then there is the problem of what is the general, or at least what is the minimum topology the user would like? Because
well, for some of these things, you could probably express it as opaque integer resources, or, you know, as node labels, as a no feature discovery container, right?
Yeah, but that goes back to why Vish was saying, like, we don't, like, even if you do opaque integer resources, you need to ensure that the actual GPU you end up assigning you to satisfies the full set of resource characteristics requested. So I guess what I'm not clear with you on, Vish, is like, do you think of it as I thought we were under the impression that we were going to need to have a way of defining resource characteristics more broadly than what we have today in the project.
Yes, so I think, so that's why I was trying to like split the problem into multiple levels. There is the issue with like representing resources and like requesting more complex resources. So that's like saying, if I want a GPU that has like, I don't know, say 24 GB of GPU memory, just going by the example here, and if it has to have like NVLink topology or like NVLink functionality, then I need to find the right node where the GPU can run. Right, like if the scheduler is going to just try nodes arbitrarily, that's just not going to work. So there are some decisions that the scheduler has to make for, like, it has to find the right node that can run this job. But when it comes to performance, which is where like topology comes into play mostly, I'm saying that it's something that's sort of like tied to quas, and given that those decisions are going to change over time, it's probably preferable to make it in the node. And I also want to add to I also want to mention one more point, which is that of like thinking from the user perspective. Users are designing their applications, and they want to know what level of availability they can provide to their applications, and they want to know like how many nines of reliability can I actually guarantee for my application, and that starts from the hardware, right? Like, so what is Kubernetes going to provide? Is it going to say that for a given job in this given class, I'm going to provide it like 99.99% availability for access to CPU, memory, GPU, and so forth. And if you think in that respect, then it's just a question of like, how are we going to meet that SLO or SLA? And so if you think from that respect, it becomes a node's problem to meet the performance goals, and it becomes a scheduler problem to find the right node to increase the probability of meeting the performance requirements. And then from an API standpoint, what is necessary is that like users can request and represent various kinds of resources.
Okay, let me put it this way. For the scheduler level, I think it's important, because if you just have the scheduler knowing that the job wants 2 GPU, and you know, oh, there are 2 GPUs on this node, if you don't check the topology and you allocate something that's cross-socket, it's better not to allocate at all. I mean, it's going to be very bad for performance. And I think users will actually prefer not to get this allocation than getting this allocation that will.
I don't think there's any disagreement there. I think that the confusion is around where the decision is being made, if I understand.
Where the decision is being made, and also how the user can specify all these in API. I mean, basically, the user has to somehow put this in like pod spec or somewhere, right? And we need to come up with a reasonably generic mechanism to specify all these details.
But then, okay, but then we're getting back to the problem of is a GPU a first class resource or not?
Yes. So, exactly. So you know what my opinion is on that. We discussed this yesterday.
I think we need something like persistent volumes, right? Like for storage, we have this API which is persistent volumes, which can represent a lot of attributes and provides a very flexible interface for choosing the right kind of storage. Similarly, we need something like that for GPUs and for maybe for other resources. Like it's just not a key value pair, or where it's just not an integer resource, but it's more like you can like have more attributes associated with it. Because basically the user knobs here are something that we have to represent in the resource. Users should be able to request for that resource.
Sure. It could be just, I don't know, I'm just thinking that it could be or like a scalar resource with some attributes. The attributes can be
I think it's probably like write up what scalar resources are.
Okay, guys, we're getting kicked out of our room, so
Yeah. I was gonna say,
continue on the documents or the.
Thanks a lot for writing this up, by the way. This is really helpful.
Yeah, all right, thank you. Yeah, we'll complete the document also a little bit. Thanks.
Thank you very much.
Well, thanks everyone, and I'll look to get a recording posted this week, and then please make sure you give your feedback on the survey as well. Thanks everyone for joining.
Thank you.